How do you find acceleration from a velocity versus time graph? Pretty easy. The acceleration is equal to the slope of the line, right? And this only works with a velocity time graph, right? You find the slope, you find the acceleration. So remember, slope is rise over run. So we're just going to have to do rise over run. And we're going to have to do it differently each time when we see a different line segment, right? So there's 1, 2, 3, 4 different accelerations because we have 4 different slopes with this graph. So for the first 2 seconds, right, you have to figure out how far it goes up. The graph goes up, how far the graph goes across. Right, so the graph goes up 4. You see it starts here at 0. By here it's 4. So that's a rise of 4, which really means it got 4 meters per second faster. And then your run is how far this graph went across, which is 2, which really just is the change in time. So the rise over run tells us the change in velocity over change in time, which is acceleration. 4 over 2 is equal to 2, right? So our acceleration during these first 2 seconds was 2. All right, then we get to this flat part of the graph, and we still find the rise over run, but as you may know, the slope of a flat line is 0 because the rise is 0. It doesn't go up or down. So no matter what you divide it by, it's going to be 0. So during this time, when it's moving at its top speed of 4 meters per second, not changing its speed, the acceleration is 0. All right, so the next part of the line, it does start off positive and it goes down into the negatives, but we're still going to treat this as one slope because the slope doesn't change during this period of time, so neither does the acceleration. And so a rise of -8 from +4 down to -4 by the end of this motion, and a run of 2. It goes from 4 seconds to 6 seconds, so that's 2 seconds that go by. -8 divided by 2 is -4, right? And so the acceleration during this time is -4. And that includes the time that it's slowing down here and the time that it's speeding up backwards, right? The acceleration stayed constant the whole time. It's basically the acceleration brought it to a stop and then sped it up in the other direction. All right, so finally for the last 2 seconds, we're going to look at the rise over run of this motion here for the last 2 seconds. The rise is 4 and the run is 2. And so 4 over 2 is 2. So the acceleration here is a +2, right? And remember, what's actually happening here is the thing is going backwards, but it's slowing down. The positive acceleration is slowing down the negative velocity, causing it to come to a stop. All right, so those are our accelerations. Again, for every different slope that you see, you have to find the rise over run, which will tell you the slope of the line, which is indeed the acceleration.